Understanding access and entrance to working space, specifically 110.26, is crucial for electrical safety. The code states that there shall be one entrance not less than 24 inches wide and 6.5 feet high at each end of the working space, where the total width of the working space is 8 feet or more. Now, let's break down what this means. In a situation involving a switchgear panel with a total width of 6 feet 4 inches, which is two sections each measuring 3 feet 2 inches, the question arises of whether two entrances are needed. Because the question mentions that the panel will be in an approximately 9 foot by 17 foot electrical room, it will be important to figure out the proper access and entrance to working space. According to the NEC, two entrances are required when the total width of the working space is 8 feet or more. In this particular case, with a 6 foot 4 inch switchgear, two entrances each a minimum of 24 inches wide and 6.5 feet high, located at opposite ends of the room where the switchgear is installed, are not strictly required by the 8-foot rule because the equipment is less than 8 feet wide. However, depending on specific installation conditions and local interpretations, having two entrances is generally a good practice for safety. The code isn't just about meeting the bare minimum requirements, it's about ensuring a safe working environment. Let's consider the purposes of these entrances. Firstly, access to equipment is essential. These entrances allow personnel to safely access the equipment for maintenance, operation, and emergency repairs. Secondly, an escape route is critical. They provide an unobstructed path for personnel to evacuate the room in case of an emergency. Think of situations like arc flash or other electrical hazards where a quick and safe exit is paramount. The NEC does not explicitly define the ends of the working space. However, it's common practice to consider the ends as the two sides of the room where personnel would typically enter and exit. In a rectangular room, these could be the two long sides. The placement of these entrances should facilitate easy access and egress. Several additional considerations are crucial. Firstly, the entrances should be accessible without having to climb over or under other equipment. This is vital for quick access and escape. Secondly, the working space around the switchgear should be clear of obstructions and debris. A cluttered workspace is a safety hazard. Thirdly, if there are other panels or equipment in the room, they should be arranged to allow for adequate access and working space around the switchgear. Proper layout planning is essential. Now let's dive deeper into the NEC and related concepts. The National Electrical Code, or NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It's part of the National Fire Code series published by the National Fire Protection Association, or NFPA. While the NEC is not itself a law, its use is mandated by state or local law in virtually every jurisdiction in the United States. It's updated every 3 years, ensuring it stays current with evolving technologies and safety practices. Article 110 of the NEC covers requirements for electrical installations. Specifically, 110.26 focuses on spaces about electrical equipment operating at 600 volts, nominal, or less to ground. This section outlines the requirements for working space, access, and entrance to ensure safety for qualified personnel who may need to inspect, service, or maintain the equipment. The specific dimensions and clearances required by 110.26 are designed to minimize the risk of electrical shock and arc flash hazards. These requirements are not arbitrary, they are based on years of experience and research into electrical safety. Understanding the intent behind these rules is just as important as knowing the rules themselves. Working space, as defined by the NEC, is the area around electrical equipment that provides enough room for personnel to safely perform their tasks. The depth of the working space depends on the voltage of the equipment and the presence of grounded surfaces or exposed live parts on the opposite side of the working space. Table 110.26a in the NEC provides specific dimensions for working space based on these factors. Access and entrance to working space are equally important. The NEC requires that there be adequate access to the working space, including doors, hallways, or permanent ladders or stairways. The size and location of these entrances are critical for ensuring that personnel can quickly and safely reach the equipment. The requirement for 2 entrances in certain situations, as outlined in 110.26c2, is intended to provide a redundant means of egress in case of an emergency. This is especially important in larger electrical rooms where a single exit could be blocked by fire, smoke, or other hazards. The ends of the working space, as mentioned earlier, are generally interpreted as the sides of the room where entrances are located. However, the specific layout of the room and the location of the equipment may influence this interpretation. It's always a good idea to consult with local electrical inspectors or qualified engineers to ensure compliance with the NEC. Several other sections of the NEC are relevant to the installation of switchgear and other electrical equipment. Article 230 covers service entrances, which are the point where electrical power enters a building. Article 240 covers overcurrent protection, including fuses and circuit breakers. Article 312 covers cabinets, cutout boxes, and meter socket enclosures. Article 408 covers switchboards and panel boards. Article 430 covers motors and motor circuits. Article 450 covers transformers. All of these articles contain specific requirements that must be followed to ensure a safe and code-compliant installation. In addition to the NEC, other standards and regulations may apply to electrical installations. The National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards for electrical power systems. The Occupational Safety and Health Administration, or OSHA, has regulations for workplace safety, including electrical safety. It's important to be familiar with all of these applicable standards and regulations. When planning an electrical installation, it's always best to consult with qualified professionals. Electrical engineers can design the system and ensure that it meets all applicable requirements. Electrical contractors can install the equipment and ensure that it's done safely and correctly. Electrical inspectors can verify that the installation complies with the NEC and other regulations. Don't try to cut corners or do it yourself when it comes to electrical work. It's not worth the risk. Electricity is dangerous and mistakes can be deadly. Always hire qualified professionals and follow all applicable codes and standards. Now, let's consider some specific scenarios and examples. Imagine an electrical room with a large switchgear lineup along one wall. The working space in front of the switchgear is 4 feet deep, as required by the NEC. There are 2 doors at opposite ends of the room, providing access to the working space. This arrangement meets the requirements of 110.26c2 and provides a safe and convenient working environment. Now imagine a similar electrical room, but with only 1 door located at one end of the room. In this case, the installation would not comply with 110.26c2 as there is not a second means of egress from the working space. This could be a safety hazard in the event of an emergency. To correct this situation, a second door would need to be installed at the opposite end of the room. In another scenario, imagine an electrical room with a switchgear lineup and other equipment, such as transformers and panel boards. The equipment is arranged in such a way that it blocks access to one of the doors. In this case, the installation would not comply with 110.26c2, as the egress path is obstructed. To correct this situation, the equipment would need to be rearranged to provide clear access to both doors. These examples illustrate the importance of careful planning and attention to detail when installing electrical equipment. It's not enough to simply meet the minimum requirements of the NEC, you must also consider the practical aspects of the installation and ensure that it provides a safe and convenient working environment. In summary, understanding access and entrance to working space is crucial for electrical safety. The NEC requires that there be adequate access to the working space, including doors, hallways, or permanent ladders or stairways. The requirement for 2 entrances in certain situations, as outlined in 110.26c2, is intended to provide a redundant means of egress in case of an emergency. Always consult with qualified professionals to follow all applicable codes and standards when planning and installing electrical equipment. Let's delve further into the specifics of working space dimensions and how they relate to safety. As mentioned earlier, Table 110.26a in the NEC provides specific dimensions for working space based on voltage and the presence of grounded surfaces or exposed live parts. Condition 1 applies where there are exposed live parts on one side of the working space and no grounded parts on the other side of the working space. Condition 2 applies where there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 applies where there are exposed live parts on both sides of the working space. The required depth of the working space increases as the voltage increases and as the potential for contact with grounded surfaces or live parts increases. For example, for equipment operating at 151 volts to 600 volts, the required depth of the working space is 3 feet for condition 1, 3.5 feet for condition 2, and 4 feet for condition 3. These dimensions are not arbitrary, they are based on ergonomic studies and practical experience. It provides enough room for personnel to safely perform their tasks without being unduly exposed to electrical hazards. In addition to the depth of the working space, the NEC also specifies requirements for the width and height of the working space. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. The height of the working space must be at least 6.5 feet or the height of the equipment, whichever is greater. These dimensions ensure that personnel have enough room to move around and perform their tasks without being cramped or restricted. It's important to note that these dimensions are minimum requirements. In some cases, it may be necessary to provide additional working space to accommodate specific equipment or tasks. For example, if the equipment is particularly large or complex, it may be necessary to provide additional depth or width to the working space. Similarly, if the tasks to be performed require specialized tools or equipment, it may be necessary to provide additional height to the working space. The NEC also addresses the issue of illumination in electrical rooms. 110.26d requires that illumination be provided for all working spaces about service equipment, switchboards, panel boards, or motor control centers installed indoors. The lighting must be sufficient to permit safe and effective work. The specific level of illumination required depends on the nature of the work to be performed. However, the general rule is that there should be enough light to see clearly and avoid shadows. In addition to general illumination, it may be necessary to provide supplementary lighting for specific tasks. For example, if the equipment is located in a dark corner or if the tasks to be performed require close visual attention, it may be necessary to provide a task light. The NEC also addresses the issue of guarding of live parts. 110.27 requires that live parts operating at 50 volts or more be guarded against accidental contact. Guarding can be accomplished by a variety of means, including enclosures, barriers, and elevation. The specific method of guarding depends on the location of the equipment and the potential for contact. For example, if the equipment is located in a public area, it may be necessary to provide a complete enclosure to prevent unauthorized access. If the equipment is located in a restricted area, it may be sufficient to provide a barrier or to elevate the equipment above reach. The NEC also addresses the issue of headroom in electrical rooms. 110.26e requires that there be sufficient headroom above the working space. The minimum headroom is 6.5 feet or the height of the equipment, whichever is greater. This requirement ensures that personnel can stand upright and move around freely without bumping their heads. In addition to these specific requirements, the NEC also contains general requirements for safety and good workmanship. 110.12 requires that all electrical work be performed in a neat and workmanlike manner. This means that the work must be done carefully and accurately, using appropriate tools and materials. It also means that the work must be properly supported and secured, and that all connections must be tight and reliable. 110.3b requires that all electrical equipment be installed and used in accordance with the manufacturer's instructions. This means that you must read and follow the instructions provided by the manufacturer of the equipment. Failure to do so could result in a safety hazard or damage to the equipment. 110.7 requires that all electrical equipment be properly grounded. Grounding is the process of connecting electrical equipment to the earth. Grounding helps to protect against electrical shock and to prevent the buildup of static electricity. The specific requirements for grounding are contained in Article 250 of the NEC. All of these requirements are designed to ensure a safe and reliable electrical installation. By following these requirements, you can minimize the risk of electrical shock, fire, and other hazards. It's important to remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the requirements of the NEC to provide a higher level of safety or reliability. For example, you may choose to provide additional working space, additional illumination, or additional guarding of live parts. The goal is to create an electrical installation that is safe, reliable, and easy to maintain. The information here is for educational purposes only. Always consult with qualified professionals and follow all applicable codes and standards when planning and installing your electrical equipment.